So in this video, we want to talk about the basic rules of algebra, and it's going to lead into a common practice called simplifying expressions that I'll be talking about toward the end, okay? But make sure you realize we're going to be dealing with expressions here, and so again, we've got to focus on that. And what we're going to see here once we get going is a lot of these basic rules are things that we think of as obvious, so it seems kind of silly, but to even mention them. But a lot of the manipulation problems that people have with algebraic expressions come from not really understanding the significance and the difference between these different properties. Okay, so the first thing we got to do is start with some really basic vocabulary. All right, so the first term we've been over, but just to remind you what an expression is, it's a combination of numbers, variables, and operations. Okay, and then we get into this more refined term called the terms of an expression, okay? And those are the parts separated by pluses, okay? And I'll say additions just to be a little bit more thorough there, okay? Now I'm going to put this part in parentheses and I'll explain why in a second, and subtractions, okay, just to get you started. But if you remember, subtractions can always be rewritten as an addition, add the opposite. Okay, and that'll be important. So just say I have, first of all, if I just have 2x plus 3, like that, then there's two terms in that expression, okay, because there's an addition. We're talking about the parts separated by the additions. So the terms are 2x and 3, okay? But if I have something like 5x minus 4, okay, like that, that's separated by a subtraction, but we want to keep up with the fact that that is a subtraction. There's some negativity associated with that. So remember that we can think about that as being 5x. I add the opposite, so plus negative 4, right? And so then the terms in that expression are 5x and negative 4. Okay, and then the next vocabulary term we get into is what's called the coefficient of a variable. Now, usually we'll be specifically referring to one, so we'll say like the coefficient of x or the coefficient of a or something like that, okay? And so what this is it's the number multiplied by the variable, okay? But remember, we use that juxtaposition idea. Let me finish writing that real quick, okay? Like that, but we use that juxtaposition idea to do multiplication. So you can think of that phrase also as being the number in front of the variable, okay, like that. So let's look at an expression that has two variables in it. Say I have 3x plus 4y plus 2, okay, like that. Then the coefficient of x is the number that's multiplied by x, so that would be 3, and then the coefficient of y, that would be the number in front of it, so that'd be 4. Okay, and this example leads into another vocabulary term to deal with this, that we're adding just a constant onto that. Okay, and so we get into this term called the constant term. Okay, and that is the term with no variable. Okay. Now, sometimes these numbers get hidden just because of the shorthand that we use whenever we write expressions. And so I'd say I have the expression just x minus y, okay, like that. By the way, in that last vocabulary term, if I asked for the constant term of this expression, I would say that it was equal to 2, okay? And so now let's look at one that has a little bit of stuff hidden in it here, okay? So remember, this will help you too. I can think about rewriting this in terms of addition. I can think about it as being x plus negative y, right, or the opposite of y. All right, and so we have this expression. There's two terms in this expression. There's the x and there's the negative y, okay? Now, ask yourself, what's the coefficient of x, okay? Well, for x, all we have is an x. It doesn't look like there's a number there. But remember, if we're multiplying by 1, we usually don't write it. And I can think about this as being 1 times x. Okay? And now there's a number clearly written there, so the coefficient of x is equal to 1. All right? That might help you with the y term, too. The coefficient of y Okay, our term there is negative y, but again, since there's not a number written there, and I'm multiplying, I can think about that as being negative 1 times y. So the coefficient on y is negative 1. Okay, what if I ask you for the constant term? This one's a little bit tricky. Okay, so we have x plus negative y. You're tempted to say none. There's not a constant term there. But what number denotes none? I could think about this as being x plus negative y plus 0 if I needed to. Okay, and so the constant term for that expression is 0. I hope that makes sense. All right, a very important basic vocabulary term is the idea of like terms. Okay, now we haven't seen very many expressions like this before because we usually simplify things down using this idea of like terms. Okay, but what like terms are? They're terms, so there'll be more than one. They're terms in an expression that have the same variable, and once we get into the world of exponents, raised to the same power. So for now, just understand that a lot of times if I just write x, okay, I can think about x as being x to the first power. Okay, so that's what I'm getting at with that parenthetical note, is that a variable by itself has power equal to 1. And that'll help you understand some of these like terms in a more basic setting. Also, just as a general note, constants, whenever there's more than one constant, constants are like terms with each other. Okay, now this might seem a little cryptic what I'm getting at without looking at an example. So let's look at an example of what I'm trying to talk about. And I'm going to put an expression that has several variables, or two variables in it. Okay, so say I have something like 2x plus 3y minus 4, and then plus 5x minus 2y plus 8. Okay, like that. And see, like terms are combinations, and there's several combinations of like terms here. Okay, and so notice that I have some x terms, and they're all, so I'll say the like term pairs. Okay, like that. And so there's actually 3 pairs of like terms here. Okay, so notice that I have some x terms, and they are both to the first power because there's no power written there, or exponent written there. Okay, so one pair of like terms is 2x and 5x. Okay, like that. And then notice that I have some y terms that are both to the first power too. Now be careful, it's 3y, and remember that I could rewrite that minus 2y as plus negative 2y. And so I would say it's 3y and negative 2y. Okay, and then the last one, constants are always like terms. And so we get negative 4 and positive 8. All right, like that. All right, let me show you one other example, and then we'll talk about what we do with like terms and expressions to simplify them. Okay, this one will only have one variable, but we're going to have exponents. So say I have, well, no, I'll do 2 variables. So say I have 3x squared plus 2y squared plus 6 plus 2x squared plus 4y, like that. Okay, so we look at this expression and we wonder if there's any like term pairs in it. Okay, and so you might want to stop and think about it, or at least why I'm writing this. Okay, and the thing is, with this expression right here, there's actually only one like term pair. Okay, so notice that I have an x right here, and it's to the second power. And so you ask yourself, is there another term that has x to the second power in it? And it's right here. Okay, so one like term pair is 3x squared and 2x squared. Now, why would I say there's no other ones? Okay, first of all, here's a 6, but there's no other constants in that expression, so there's no constant like terms. And then why are the y's not like terms? There is a y in both parts of this, but this one is to the second power, and this one is to the first power. So what's the big idea about noticing like terms is we can actually combine like terms, okay? And so what that phrase means is that you add or subtract the coefficients, okay? But you keep the variable unchanged, and I'll explain why. Okay. All right, like that. But just really quick, say I have something like, uh, 4x plus 3 plus 3x plus 9. Okay, ask yourself what the like term pairs are there. Well, the x terms are like terms, and the constants are like terms. Now, some of you you'll get to the point where you probably do this in your head and just go to the next step with the answer. But to help you, what I often do, and we'll see later, we'll see some really complicated expressions that have lots of like term pairs. And so sometimes it's advantageous to group them together like that. Okay, and now what you do to collect them is you keep the variable unchanged, and then you just add or subtract the coefficients. I would subtract if that were a minus 3x, if you're wondering. So I'd say this is 7x, and then I do the 3 plus the 9. I get plus 12. Okay, like that. Now you might be wondering why this works. I'm gonna show you with a more basic one, just so we don't have to write so much. Say I have 2x plus 3x. Why am I able to add those coefficients? Well, we got to remember back to basics. What does 2x mean? I'm multiplying x by 2. Multiplying is repeated addition. So this is really x plus x. Okay, like that. And then plus, same thing here with 3x. I have 3 repeated additions of x. So I have x plus x plus x for the second part too. So what have I done? I've repeatedly added x 5 times. And how do we express that with multiplication? That's exactly what 5x is. Now, we don't want to have to write that out every time, so that's the reason we realize this property of combining like terms. We don't want to have to do this part right here. So we usually just learn that concept of combining like terms and go straight to there. Now, just be a little bit careful with subtractions, okay? And so say I have 5x plus 4y minus 3, and then minus 2y. Sorry, I meant to say minus 2x. And so minus 2x minus 4y plus 1. Okay, so now hopefully you see that we have our like term pairs, and so I'm going to rewrite them grouped together. So I have 5x minus 2x plus 4y minus 4y, and then minus 3 plus 1. Now, one important note here, too, is notice that I've moved things around that were subtracted. I'm technically using the commutative property of addition, so I'm thinking about rewriting this as plus negative 4y, and this is plus negative 3y. But we don't have to do that. And one thing to try to avoid is cluttering up a lot of work with pluses and minuses and so on like that. And so the key thing is you can move these things, you can move the subtractions around. Just make sure to keep that subtraction attached to it. Same thing here, minus 4y, so I want to write that as minus 4y. Okay, and so now I'm ready to collect my like terms. And so we have 5x minus 2x. So the x stays there, and I just do 5 minus 2, which is 3. Okay, now this one gets a little bit tricky, but don't overthink it. Just 4 minus 4 is 0, so I have my plus 0y. And then here I have negative 3 plus 1, so that's negative 2 or minus 2. Okay, now remember that 0 times anything is 0, so this whole part right here equals 0. And then whenever we add 0 to something, it doesn't change anything. So anytime you have 0, you can just drop it out of your expression. And so we get 3x minus 2. Okay, so now this kind of starts leading into the idea of simplifying too. And I'm just trying to give you a preview whenever we talk about it. But here we started with a fairly complicated expression. It had 6 terms in it. 1, 2, 3, 4, 5, 6 terms in it. Okay, but notice by doing this algebra and collecting like terms and so on, I was able to get it down to an expression that only had 2 terms in it. So that's the idea of simplifying expressions, is trying to get them down as compact or small as possible. All right, now we're ready to start getting into some basic properties of expressions. And so, and just remember, variables represent numbers, and so these properties actually come from addition, come from arithmetic. Sorry about that. So just as a quick example with numbers, and we've mentioned this before, remember whenever we add if I'm doing 2 plus 3, I can think about that as just being, I'll get the same result if I do 3 plus 2. So it doesn't matter what order I add things in, okay? And that's called the commutative property, okay? But this, remember, not everything, we can't always do that. Remember, it does matter what order you subtract things in, okay? And so we need to refer to what operation has that commutative property. And so we call that the commutative property of addition, okay? Now, and so we can apply that as long as we're adding. We can apply that even with algebra. And so I'd say I have the expression 3 plus x, okay? It's fine in a lot of cases to leave that written that way, but sometimes we like our variables to be out front. And so just like I can rewrite 3 plus 2 as 2 plus 3, I can reverse the order. I can reverse the order here. Now again, it's because I'm adding, okay? And so I get, I could rewrite that as x plus 3. All right. Now you can use the commutative property with addition, but you just got to be careful, okay, that the commutative property doesn't apply to subtraction, okay, but it does apply to addition. So if I want to, I can rewrite that as 3 plus negative 2x, right? Add the opposite like that. And so now I am adding, okay, and as long as I keep that negative attached to the 2, I can reverse the order of these two things. And so I could rewrite that as negative 2x plus 3, and then typically we would drop those parentheses because it's just grouping something in our answer. And so we would say negative 2x plus 3. Now ask yourself, is there another operation that it doesn't matter what order you do things in? And the answer there is yes. If we think about it, if I'm going to do 2 times 3, I could do that I would get the same answer as if I did that as 3 times 2. So multiplication also has that property, okay? And so we get into the idea of the commutative property of multiplication, okay? And so what's going to happen, sometimes in algebra you'll end up getting something that looks like this. Just by doing some work, you'll end up with x times 2. But what is that commutative property telling you? We usually write the coefficient out front, and so I can reverse that around and write that as 2x. Okay. Now, if I have an expression that looks like this, x plus 3 times 2, like that. Again, this 2 is kind of acting like a coefficient. All right. And so often we want coefficients out front. You just got to be careful. Well, where is the multiply at? The multiply is right here. So I can apply the commutative property of multiplication here and just write those in the other order. Well, I won't even point that out until after I've written it. So I could rewrite that as 2 times x plus 3. All right. Now, again, you might be saying, well, if I'm going to do that, why wouldn't I use the commutative property of addition to rewrite these two too? It's because of that convention that we usually write variables first and then numbers. And so this would probably be the preferred form to use that. Now, also, remember with these properties, there's a commutative property of addition, and there's a commutative property of multiplication. But remember, it matters what order you subtract things in. It also matters which order you divide things in. So there's not commutative properties for those two operations. Now, I did show you that you can kind of pull a trick with subtraction. You can kind of do the same thing with division, but it's complicated. You have to resort to fractions, and it just gets a little bit confusing. That I think adding that in would just add an extra layer that would probably confuse most people. So the main point there is to realize you can't reverse the order of division. Okay, and the next two properties are important, and we use them often. Again, it's just like with the commutative property. They just kind of get buried behind the scenes, but then you start doing more advanced algebra work, and you wonder if you can do something or how you do something, and it's usually revolving around these properties. Now, the next property we're going to talk about after this is called the distributive property that you may have heard of in the past. Okay, and people get these two mixed up, the associative properties and the distributive properties. So try to be careful with this. Okay, now first of all, let's just look with numbers. Okay, and just ask yourself this question. Say I told you to do 2 plus 3 plus 8. Okay, you don't necessarily need to pause, but actually compute what that is in your head. and see how you think about how you did that. Okay, so probably the way most of you did this is you took the 2 plus 3 and you added 5. You got 5, and then you took that and you added on 8, and you got 13. Okay, some of you, now, so we do get 13 here. So some of you may have done this instead. Okay, there's actually a third way that incorporates commutativity too, but some of you may have just saw these last two numbers and decided to add those. And so you got 2 plus 11. 2 plus 11 is also 13. Okay, and that's an illustration of the associative property. And what it says, I'll write it out too, but what the associative property says is that if you, first of all, notice I have the same operation, and that ends up being the distinguishing factor between associativity and distribution. Okay, that if I have the same operation more than once, okay, like that, then how do I proceed? I take any two of them and add them together, okay, and then I add on the third one to the result. And further, what the associative property says is it doesn't matter which two you group together. Okay, so I get the same answer if I take the 3 and the 8 and then I add 2. That third way that I mentioned that some of you may have caught, because 8 and 2 add to 10. Okay, some of you may have added these two together first and got 10 plus 3, which also gives you 13. Okay, that's combining the associative property with the commutative property really behind the scenes. It's just our brains get so used to those kind of things that we don't really think about what property we're using whenever we're doing it, especially whenever we're just dealing with numbers. Okay, so what the associative property for addition says, okay, I'll just say for add, but if you're taking notes, I'd say addition. What it says, now remember, we use variables to, one use of variables is to illustrate general properties. And so this is a general property, so I'm going to use variables. So it's saying that if I'm adding three numbers together, okay, so A, B, and C are representing numbers, I could take the first two and add them together and then add the third one, or I could take the last two together, add them first, and then add on the first one. Okay, so I hopefully you see what that property is trying to say. But in words and in general concepts, what it's saying is that anytime you're adding more than two things, I could just easily put on a plus D here. Okay, what the associative property is doing is saying is that you're adding more than two things together. You can just take any two at a time and then add on the third one. Okay, like that. Now let me show you a basic use in algebra of doing this. Say you had an expression that looked like this: 2 plus 3 plus x. Okay, it doesn't look like there's a whole lot you can do with that thing, but see here I have three things that I'm adding together. I'm adding a 2 plus a 3 and plus an x, but I can't add these two things together yet. Okay, they're not like terms, and so but what I can do is I can use that associative property. So the way this is written, it's like this part right here. Okay, but the associative property says I can regroup that into adding the first two things together. All right, and so instead of writing it that way, I could just as easily write it where the 2 plus 3 is grouped together, like that, and then I would end up with 5 plus x, something that I can combine together to make simpler. And that's, you know, once we're going to talk about a specific phrase we see a lot in math, simplify the expression. In general, that's what simplify means. It means just to try to make an expression as compact as possible. Okay, so then there's the idea of the associative property of multiplication as well. And so I'm just going to write the property because it extends. It's just like addition. So what it has to do with is whenever you're multiplying three or more things together. Okay, same thing with numbers. Let's just do this, but I'll erase it. Say I told you to do 2 times 3 times 5, like that. Then just like with addition, you would group those two things together, and you'd get 6 times 5, and then you would get 30. Okay, or we could have done this as 2 times 3 times 5 and grouped these two together, and then got 2 times 15, which gives us the same thing as 30. And then again, combining with commutativity, you may have noticed that 5 times 2 is 10, and then multiplied by 3, and that gives you 30. Okay, and so That's the idea of the associative property of multiplication. It's just that you're multiplying three things together. And so what the associative property tells you is that you can group any two of them together like that. And then, like I said before, you could even multiply the first and the third one together and then multiply it by the second one, but that's combining with the commutative property. All right, and just like with addition, what will happen is in algebra, some expressions will come out looking strange, and so you just got to pause and ask yourself, is it okay to do what you're doing? And the way you justify it is with one of these properties. So here I have 2 times 3 times x, but the 3x is in parentheses, okay? But what does this associative property allow me to do? So notice I haven't written any multiplies, and if it helps you, put them in there. There's 2 multiplies there, so I'm multiplying 3 things together. The associative property tells me that it doesn't matter what order I do that in, and so I could just as easily group that 2 and the 3 together like that, and see I can do 2 times 3, that's 6x. You know, as I have it written, I would probably have parentheses, but we usually drop them at the end. Okay, now the key thing to distinguish, we're about to talk about what's called the distributive property. Okay, and the key thing to distinguish between when to use the associative property and when to use the distributive property is with the associative property. First of all, you have more than one operation. Okay, for both of them, for the associative. But with the associative property, the key way to realize or recognize whenever using the associative property is that the operation is the same. Okay, like that. And I will tell you, associative property in this case, the associative property actually applies to subtraction and division as well. But that's more just following order of operations. Okay, so that's it. But once we talk about distribution and you find yourself confused, the difference is with the associative property, you're doing more than one operation, but they're all the same operation. Okay, what we're going to see with the distributive property is we'll have 2 different operations. Okay, so here we go. We're going to talk about the distributive property. There's some very technical wording here. Most often, once we get used to it, we usually just say the distributive property. And the action of using the distributive property, people just say distribute. Okay, but the technical name is the distributive property of multiplication over addition. Okay, and so I'm going to start this one with an example and explain why we need this. Okay, so look at this expression right here, 5 parentheses x plus 3. And so remember, there's really a multiply right there. So if it helps, you put it in there. Okay, what's the problem here? Think order of operations. The order of operations says that I would do the parentheses first. So I would need to do this x plus 3 first. All right, but what's the problem there? These things are not like terms. X and 3 aren't like terms, so I can't combine them together in any way. So what the distributive property allows us to do, it kind of allows us to break the order of operations here. Okay, what we can do is we can take this 5 and multiply it in times the x, and then multiply it in times the 3, and keep this sign in the middle. Okay, so there will be a plus right here. All right, and so I multiply the 5 times the x, and then I multiply the 5 times the 3. Now, I will tell you, people end up feeling like they can't really get this down, and you probably will make at least a few mistakes. Some people make mistakes with it all the time. And just in general, this happens all the time, even in high-level classes. It's just one thing to try to get careful of, and so you're not always making this mistake. People are really good about this step, getting the 5 times the x, and then they forget to do the second part. They'll just write plus 3 here. They'll forget to multiply times the distributed number. Okay, and so now there's not anything else I can do with that 5x, but I can say what 5 times 3 is. It's 15. Okay, one thing to note too, the distributive property does does apply to numbers. Any algebraic property also applies to numbers, since variables just represent numbers. People use it that do a lot of mental math use the distributive property a lot, because say I had something, if I were trying to compute 5 times 13 in my head, all right, like that. So, some people can do the multiplication algorithm in their head to get that. But notice that multiplying by 10 is pretty easily. So what people will do, I do this all the time if I need to do a mental calculation. I'll rewrite that number as something simpler numbers that I do know how to multiply with. So they'll write that as 10 plus 3, and then they'll distribute this all in their head. It's pretty complicated. There's some people that are really good at doing mental arithmetic. So if I distributed that, I would get 5 times 10 is 50, and 5 times 3 is 15. And so getting those two multiplies, and then see you have some pretty basic numbers to add together there. And so you get 65. All right. Now, one other thing while I'm pointing this out too, on this little sidetrack, don't confuse this with order of operation stuff and try to overuse the distributive property. Where we really use the distributive property is by the order of operations. I should be adding in this parentheses first, but I can't add those because they're not like terms. All right. But if you have all numbers in there, okay, if you have 5 times 13 plus 8, okay, well, these are like terms. Constants are like terms, so I can do the parentheses there first. And so typically you want to go ahead and add those together first if you can, okay, but you don't necessarily need to. You could use the distributive property. I'm not saying you get it wrong if you use the distributive property there, but I've seen a lot of students start making errors with just basic arithmetic because of trying to overuse distribution. Okay, so now let's look at this general property here, okay? And so let's just state it in general, all right? What the distributive property it deals with is that you have a number multiplied by a sum, okay, like that. And that's the reason it's called the distributive property of multiplication over addition, okay? And that's the key thing in distinguishing between the associative property. Here I have two operations on 3 numbers. I have what are they? They're different. I have a multiply and an add, okay, like that. So if this expression were a plus b plus c, I would use the associative property. But since I'm multiplying times a sum, I use the distributive property. And just following that example, what does this say to do? We take this a and distribute it over those parentheses. So I get a times b plus a times c. And that's called the distributive property. Now, multiplication also distributes over subtraction. And so there's a distributive property of multiplication over subtraction. One way to realize that that would be true is to understand that I could rewrite that as plus negative c, and then I'd be using the regular distributive property. But you can skip that step and hopefully just trust me that it works. So we get a times b minus a times c in that case. Okay. Moreover, we won't get into this now, but just to point that out, division actually also distributes over addition and subtraction. We'll see that later, so I'm going to hold off on that. Okay. That's the general idea. And the reason it's called the distributive property is, in a sense, you're distributing that a, but you got to distribute it over the entire expression, whatever you're doing, addition or subtraction. So don't forget to multiply it by anything that's after the first term. The other thing to notice too is notice that the operation stays the same in the middle, whether you're adding or subtracting. Okay, let's practice that with some examples. Okay, so here's going to be our first 3 examples with distributing. So the examples say to distribute, and so we're just going to perform the distributive property. One thing too, if you want to pause and try these, don't let number 4 throw you. There's 3 terms here. You do it just like you do with whenever there's only 2 terms. You distribute the 4 over every term in that expression. So yeah, if you're feeling comfortable, I'll pause right now. I'm about to get going now. Okay, so in problem 1, we have 3 times parentheses 2x plus 4. Again, remember, these can't combine in any way because they're not like terms. And so I'd want to distribute that 3 over these 2 terms. Okay, and so I have 3 times 2x and then plus 3 times 4. Okay, now 3 times 2x, you might be asking, can I multiply that 3 and the 2 together? And that's where the associative property comes in, because there's a multiply right there. And so I'm multiplying 3 things together. I can group any 2 of them together. So I can multiply that 3 times the 2. So that actually gives me 6x, and then 3 times 4 is 12. So I end up with 6x plus 12, like that. Okay? And so now you don't have to explicitly think about the associative property when you're doing that. Just realize if you're multiplying and you have a number in front of a variable, you can multiply those two numbers. But the reason that you can do that is the associative property. Okay? On this one I have 6. I want to distribute the 6 over them. The only big difference here is that I'm subtracting. So that subtraction stays in the middle, and so I end up with just 6x minus, you can do this the way I did in the last one. You could say write 6 times 3 and then get the 18. A lot of people at least get to the point where they can just multiply those and go straight from here to there. Okay? And then, like I said, if there's more than 2 terms inside the parentheses, the principle works the same. You just distribute over all of these. Okay? Now notice here I'm subtracting and here I'm adding. And so I just keep those in there. So I get 4 times 2x minus 4 times 3y plus 4 times 5. Okay? Like that, and then just as before, I can multiply the 4 times the 2 to get 8x, and then minus 12x, and then plus 20. All right, now let's look at what happens whenever we distribute negative numbers. Okay, so here's 3 examples to get progressively harder if you want to pause and see how you do with them. Otherwise, I'm going to progress. Okay, now don't let negatives throw you. It does get a little bit more cluttered. And I'll show you some shortcuts after we work through these too. Okay, so anyway, it works just the same. Okay, so in this first one, I take that negative 3 and I distribute it over these two. Now remember that at first the sign in the middle just stays there. It's going to end up leading into one of our shortcuts where whenever we distribute it negatives, we might not necessarily write that there. But but at first, just nuts and bolts, we have negative 3 times 2x, and then plus negative 3 times 5. Okay, like that. So just as before, it's just now we have sign numbers to deal with, but we have negative 3 times 2, that's negative 6x, and then plus negative 15, right? Like that. Now, remember, at the end, and this is practice, and we don't want to do this. At the end, this is kind of like reducing fractions. Remember, whenever your answers are fractions, you should look at the end to see if anything reduces. What you should do at the end of an algebraic expression, too, is to see if there's any cleanup to do. And notice that we have this plus and minus next to each other. So you typically only want to have one operation in between numbers. And remember that that's the idea of subtraction. I can rewrite it as plus and negative. So I can combine basically anytime you have a plus and minus or minus plus next to each other, you can rewrite that as a minus. And then anytime you have a minus minus, you can rewrite that as a plus. And very rarely, but sometimes you might end up with plus plus. Okay? So all I'm getting at here is we can rewrite this right here as a subtraction. So we would say negative 6x minus 15. Okay? Like that. Now this is one with 3 terms in the parentheses, but it still works the same. I'm just going to distribute that negative 2 over all 3 of those terms. All right, so I have negative 2 times 3x. Remember the sign stays, so there's a minus, but then I'm distributing negative 2. Okay, and then this plus is from here. Again, that minus is from there. Okay, like that, but I'm distributing negative 2 also, so I have negative 2 times 1. Okay, so on my leading term, I have negative 2 times 3, so I have negative 6x. Again, that was in the last example. I just realized that. Okay, now you might notice this here. Okay, these 2 minuses are going to make a plus now. So I have plus. Now all I need to do is do 2 times 2. Okay, like that. So some people recognize it that way. Some people, let me go back and then I'll go back. Some people go ahead and do negative 2 times 2, but that's negative 4, so you'll end up with 2 negatives anyway. That'll end up creating a plus. So in the middle here, we actually end up with plus, and then in this case, the way I'm doing it, I'm combining these now into that plus. So I just do 2 times 2, and I get 4y. All right, and then here, notice that I have a plus and a minus, so I could rewrite that as minus and then I just do 2 times 1. Okay, I got that so cluttered up, I'm going to just rewrite the answer where I can see it more easily. Okay, well, there's the answer there. Okay, now last one here, look at all these minuses that we have here. All right, so but the key thing is I'm going to distribute that -4. And at first, remember, these operations these numbers just stay there. Okay, so I have -4. The leading one's a little tricky, but I have -4 times -x. And then minus, this minus right here is from that. But then I'm also distributing -4. So then I have another negative, -4 times 3y. Okay, same thing here. There's a minus right here, so I'm going to write it down right here. But then I'm distributing -4. Okay, so -4 times -x, I have these two negatives that are canceling each other. So that ends up being plus 4x. Okay, like that. And then here I have a minus, so that becomes plus. Okay, now you got to remember, what's creating that plus though? What's creating that plus is this right here, this minus. That just became a plus. So what's left, I just do 4 times 3. So whenever I combine those two negatives into a plus, they go away. And so I'm just doing 4 times 3, not -4 times 3. So then I get 12y. Same thing with that last term. I have a minus, so that makes a plus. And then I just do 4 times 5, which is 20. Now I was referring to a shortcut. I'm not gonna say it as a shortcut. I'm gonna say it as a check. Whenever you're distributing a negative, let's look at what happened from what started inside the parentheses in terms of signs and how the answer came out. So notice on example number 4, I had a positive and a positive, right? Like that inside my parentheses. And then what did I have in my answer? A negative and a negative. Okay, like that. Let's look back at number 5. Inside my parentheses, I started with a positive, a minus, and a positive, or a plus, a minus, and a plus, however you want to think about it. And look what happened in my answer. I had a minus, a plus, and a minus. So what I'm trying to get at here, this is a good example to illustrate that. Whenever you distribute a negative, in the answer, the sign patterns will reverse around from what started in the parentheses. And that way you can check your answer at least that the signs are correct. You may have mismultiplied, so you might still have an error. But the main issue people have is keeping up with all those pluses and minuses and stuff. So you can use, if you can remember that fact, then it'll help you. Whenever you distribute a positive, like in examples 1 through 3, you might want to scroll back and see that. Whenever you distribute a positive number, the signs stay the same. The sign pattern stays the same from the parentheses to the answer. Whenever you distribute a negative, then the sign pattern inside the parentheses reverses in the answer. Okay, so let's look at that with example number 6. Here I started with a minus, minus, minus. So what should be the sign pattern in my answer? Plus, 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 and notice that's exactly what I had. So I at least know that my signs are correct. So now we're ready to combine everything that we've talked about in this lesson. And I've already mentioned this, one half of this right here. We're going to see this a lot as you go through algebra, and there'll actually be extra steps added on too later. But we're going to talk about this idea about simplifying an expression, or sometimes we'll say simplify an algebraic expression. Okay, and so the idea again of simplifying in general is just to get the expression down as compact or to have as few terms as possible. So the thing is that if there's parentheses, okay, like that, use distribution. It's usually distribution. Sometimes it's associativity. Okay, to clear the parentheses. Okay, and again, remember, if that just confused you, I just thought of that whenever I was writing. It's usually distribution, but sometimes it's association or the associative property. Okay, and so remember the distinction between those two properties is that you have three things that you're performing two operations on, two or more operations on. Okay, you're using association if the operations are all the same. You're using distribution if the operations are different. Okay, all right. So if there's parentheses, you clear them usually with distribution, but maybe sometimes association. Okay, and then all you do is collect any like terms. Okay, and that's it for now. Okay, so you just got to be careful, and this is going to be your first step into dealing with what will end up being very complicated algebraic expressions. We'll start pretty light, but like I say, depending on how far you go in algebra, sometimes you get very, very complicated. Okay, so I'm just going to say simplify, but in your book or in my directions, I would usually say simplify the expression or simplify the algebraic expression. Okay, so anyway, let's say I have 5 times 2x plus 3, and then I have plus 2x plus 1, like that. Okay, so notice that there's parentheses there, and so I want to distribute. Why do I need to distribute? Because I'm multiplying times a sum. So multiplication over addition. All right. So I distribute that 5 and that. Now, why do I claim there's no distribution, no other distribution there? Because this rest of it's not being multiplied by anything. There's not anything in parentheses. Also realize that the parentheses limit where things end, stipulates where things end. Okay. And so I don't want to distribute that 5 over these two terms. That 5 is only being multiplied by these two things. Okay. So 5 times 2x, hopefully you're starting to get a little used to this. You can write it out explicitly like I was doing in the last examples, or if you start seeing things, I get 10x. The main thing is people are really good about getting this term, but what they'll do, the very common mistake is to say plus 3. What's that person forgetting to do? They're forgetting to distribute that 5 over the 3 as well. Okay, so writing plus 3 is incorrect. What should we write? 10x plus 15, because that's 5 times 3. Okay, and then I just have this plus 2x plus 1 here. Okay, now are there any like terms there? And we do. We have these 2x to the first term, so those are like terms. And then notice, remember that constants are always like terms, so I can combine those two together as well. All right, and like I say, if you need this step, especially once things get more complicated, I do it all the time. The more complicated things are, the more careful I become. Okay, and so that step you can have in there, you don't necessarily need in there. It just depends on your number sense. And so we got 10x plus 2x is 12x, and then plus 15 plus 1, that's 16. And then notice these two things aren't like terms, so I can't combine them. So that would be the answer right there. Okay, what about if I have 4 times x plus 2, and then I have another parenthesis, plus 2 times 3x minus 8. Oh boy. Okay. And so I say, oh boy, but once you get comfortable with it, hopefully it won't be that much of a problem. Key thing is I distribute the 4 over the x plus 2, and then I'm going to distribute the 2 over the 3x minus 8. Okay. So in my first one, I have 4x plus what? What do I get? Think about it. Remember to distribute that 4. 4 times 2 is 8. Okay. And then plus, now I distribute the 2. 2 times 3 is 6, so I get 6x. And then minus 2 times 8 is 16. And like I say, don't feel like you have to skip steps. I'm kind of skipping that middle step there. So take as many steps as you need to get it right, not to get you through the assignment as quickly as possible. Okay? And so notice that I do have like terms. I have the 4x and the 6x, and then I have the 8 and the minus 16. Okay? 4x plus 6x is 10x. 8. Now this is a good one right here. So we have plus, but then we have 8 minus 16. That's negative 8. Okay? But what should I do there? I should clean that up because I have a plus and a minus. Now some of you end up realizing you're going to get that negative. So some of you can go straight to 10x minus 8. Some of you will need that middle step in there. So it just Kind of depends on what you see. Just make sure you're getting things right is my main thing. Okay, so here's a very interesting one. There's a lot involved in this, and you might end up being surprised at the answer. You folks that are more comfortable, you might want to pause and try it. Feel free on any of these where that I forget to after I have it written. Always feel free to pause and try it if you want. Okay, so again, notice that I have two things to distribute here. I have this -3 in my first parentheses, and then this 6 to distribute in my next parentheses. Okay, and so in my first one, I distribute that -3. Now with that negative, you might want to be a little bit more careful and actually write those steps out. So if you've been wondering what I'm talking about, writing more steps, remember in those first examples, I was explicitly writing -3 times 2x. Then I just started doing the multiplies in my head. Okay, so be careful. I'm going to get a minus from that sign right there. So that minus is from this. But then I'm distributing -3, so I have -3 times 4. Okay, like that. So, and then plus, okay, now I distribute that 6. That one's a little easier to do. So I have plus 6x and then minus 12. Okay, so we have that. So now we got some cleaning up to do on the front end. So we have -6x. And notice I have those two negatives, so they make a plus. If I'm going to combine the two negatives then all I do is 3 times 4, which is 12. Okay. Now, some people, and let me just point this out, some people do it slightly different. They'll do the -3 times 4. They'll get -12, but then that minus is still there. So then at that point, you have the two minuses that make a plus. So it's kind of up to you when you handle that, those double negatives. Just remember if you do it before like I did, okay, if you do it before, if you're going to combine these two now into that plus, all you do is multiply 3 times 4. Okay, you don't multiply. Do you see what I'm getting at? If I make these two a plus now, then I don't do -3 times 4 because I've used that negative right there twice. Okay, so now I just keep going. I get plus 6x minus 12. And look, like this is kind of interesting. You might start seeing it now. I start getting my like terms lined up. -6x plus 6x, and then plus 12 minus 12. Okay, like that. And so remember we saw this earlier. -6x plus 6x, that's actually 0x. And then 12 minus 12 is 0. I'm being really explicit on this one. And then remember 0 times anything is 0, plus 0. 0 plus 0 is 0. Okay, very strange answer there. But don't let it throw you. You know, on these ones where you end up with a weird answer, you might want to look back through or retry the problem. Make sure you didn't make a mistake in there. But 0 is a perfectly legitimate number to get. It's also legitimate to get, start with a variable expression and end up with a number. What this calculation is showing is that, remember, x represents any number. So what it's saying is that if I actually filled something in for x, so say I was set x equal to 22, and I went through and I calculated this whole thing following the order of operations, no matter what number I picked for x, I would get 0. So if I picked x equals 22, I would get 0. If I picked x equals 4,621, I would get 0. If I picked x equals 5/7, I would get 0, etc., on down the line. Okay, now a couple more that get more complicated with negatives. All right, so we have this one. Now this one will throw people, and there's a way to do it, and that ends up being kind of cluttered with all these pluses and minuses and stuff. So I'm hoping that I can show you a slight shortcut on this. But if not, just do it this nuts and bolts way. Just get comfortable with how to combine pluses and minuses together. Okay. The key thing is it's in the middle here. It's this. Okay. What am I actually doing here? This is actually a subtraction. It's subtracting 3 times all of this. Okay. But remember, we can always rewrite a subtraction as plus the opposite. So the way I would handle this at first is I would say I wouldn't distribute until the second line myself, but then plus -3 times 2x minus 5. And if it helps you could put that -3 in parentheses. Okay, so what am I really distributing in that second part? I'm really distributing -3. Okay, like that. So now, and then in the first part I have the 4 to distribute, right? Okay, so I do 4 times x, that's just 4x. And then I do 4 times 1, which is 4. Okay. Now, here I have plus, and then I do negative 3 times 2x. So that's negative 6x, because negative 3 times 2 is negative 6. Okay, and then remember that at first, this sign stays here. Okay, so I have minus from the inside of my parentheses. But then I also have negative 3 times 5, which is negative 15. Okay, so we're almost to the collecting like terms, but we have some cleanup here. Notice that here I have a plus and a minus, and here I have a minus and a minus. Okay, so I want to clean those up. Oops, switch back to my pen here. And so I want to clean those up. So I have 4x plus 4 minus 6x plus 15. Okay. All right. Now, some of you can do this in your head without it. I usually like to rearrange things. So we have 4x minus 6x plus 4 plus 15. I like to rearrange things where the like terms are together. And again, too, remember if you're moving things around, just make sure if something has a minus on it to keep it attached there. Same thing with pluses. Don't change the signs unless you're multiplying it by negative or something. Okay, so anyway, what's 4x minus 6x? That's negative 2x. And then 4 plus 15, that's 19. Okay, now there's just a few steps you don't need here. And so it's kind of up to you how comfortable you get. And if you're going to try some of these shortcuts in the homework, what I would do is I would try them with odd problems first. So you can look them up in the homework or in the back of the book to see if you're getting them correct. Okay, but the way some people will handle this problem is they'll just realize that you can do this. And so they'll just distribute negative 3. Okay, and they'll go, well, negative 3 times 2 is negative 6. And realize that that's going to create a subtraction. So they'll actually go straight from here to right here, okay, like that. And then they'll also say, well, I got negative 3 times negative 5. That's going to make plus 15. And so they'll go to here. Okay, just be very careful about jumping to that kind of shortcut. It's fine if you do, and it's great if you do, but make sure you're getting things correct before you start trying to use that widely. Or otherwise, if you're making mistakes, I would take it more step by step, and then just try to get comfortable combining these plus minuses and minus. All right, let's do one more where we have negatives all over the place. Okay, so here's my answer on problem 4. And on problem 5, let's say I have negative 2 times 3x minus 1 minus 5 times 2x minus 3. Okay, here we go. All right, so, I'm going to do it the slightly slower way. Hopefully, if you feel like, well, that's a good chance. If you feel like you're comfortable with this shortcut way that I was just trying to point out, try it with this one right now. Pause me, and I promise I don't mind being paused. It's done to me all the time. And so, yeah, go ahead and try that. But I'm going to go ahead and carry on. Okay? So the way I would do this, or the way I would advise doing this if you're not very comfortable, is just changing that to plus minus 5. Okay? And then now just realize you're distributing negative 5 right here. Also, we're distributing negative 2 right there. Okay? So I have negative 2 times 3x. So that's negative 6x. And then I have the minus from what's inside the parentheses. And then I have negative 2 times 1. That's negative 2. Okay, and then I have plus. Now I'm doing negative 5 times 2x. That's negative 10x. And then I have this minus. Again, in both of these, the first minus is just because there's a minus in parentheses. And then on this one, the second minus is because I'm distributing that negative 2. Same thing here. I have negative 5 times 3, okay? And so it's the reason I'm multiplying by 3 is I rewrote that minus right there. So that's getting accounted for. And so I have negative 5 times 3. All right, like that. All right, and so now we just have we have negative 6x, and then we have 2 minuses that make a plus. And then we have a minus plus minus, so that makes a minus 10x. and then we have a minus minus, so that has 15. Okay, like I say, some of you can look at this. It's just so ingrained in me. It's part of the reason I always regroup those whenever I'm collecting like terms, or almost always. Okay. Also, well, just from my past, you're doing a complicated problem like this, you're really focusing through here. You get to this step, you realize you're near the end, so you just collect these things in your head, and you do something silly like -6 plus 10 without realizing it. Okay, so that's where people can go astray. And so now we're just ready to finish. And so we get -6 minus 10. That's actually -16x. And then we have plus 2 plus 15 is plus 17. And there's our answer right there. Okay? All right. So that's pretty much the full gambit of simplifying that we'll see for now. But like I say, as you progress through, and even later in this course, we'll see some more complicated examples. But that's it for now. So I hope that helps. And let me know if you have questions. And all the best to you.